Okay. Okay. So I've been with IBS since the last 6 years, and we have done this diploma. I think six. This is the sixth badge, and almost 99% of you are always industry professionals. And the purpose of this diploma is to basically try and bring a change in the industry. So I was the one who designed this diploma maybe 4 or 5 years ago. When I joined IBF, maybe less 1 year after that, we started this diploma, and we have been changing the curriculum from time to time based on the requirement. So big data analytics was quite a famous, technology 5 or 6 years ago, and still it is there because when we talk of big data, we typically think about Hadoop. Okay, so we think I think all of you must have heard about Hadoop. Heard about it, right? Suna to hoga, huh? So we think big data means Hadoop in most cases, or we think that big data means MongoDB. Okay. So, but we need to be very clear on, what is big data, and do we have big data in the company? Do we need to do something? If we have big data, do we need to do something different? Or more important than that, what exactly do we do with the data in our organizations? Well, first of all, what can we do with the data? That's the first thing we need to understand, right? क्या क्या हो सकता है डेटा के साथ? What are the possibilities, and what can we do with the data? उसके बाद, do we need to change anything if we have big data? So ये तो because there's a difference between small data and big data, right? There has to be difference. So all of us know that it is the size. One thing that we understand is the size of the data. So if talking about terabytes and gigabytes, we autonomously we think, yeah, yes, this is big data. And when we talk about megabytes and kilobytes, so we think, yeah, this is small data. Okay. So it also depends, what are you processing every day? How much data are you processing every day in the company? That's also very important. So every day you're working with megabytes to kilobytes of data, or kilobytes to megabytes. That's okay. That's small data. That's not very large. But if every day you are dealing with several tens or hundreds of gigabytes of data, you have to query that data. Then obviously you have big data. Okay? So it is defined more by the everyday operations that you do. Okay, so or from the analytical perspective, the weekly analysis that you have to present to the boss, or maybe the monthly analysis, or maybe the quarterly analysis. So if doing in any type of daily operational work, or the weekly or the quarterly or the monthly work, you have to work with data which is uh, more than what makes you feel comfortable. Let's define it that way. More than what makes you feel comfortable with your own laptop and your own software. For example, you are using MySQL front end as your backend database, and you have the MySQL front end. You have any tool for that, and you are querying several hundred megabytes of data every day, and you're running maybe 25 to 26 queries, 25 to 30 queries every day. So it's okay. Okay. But if one day you have to query, let's say 1 gigabyte of data, so obviously the query is going to show some degradation of performance. That's an obvious reality, right? So then that is a slight indication that there is a big data problem. Because SQL is a pretty good language. It was invented in 1980s when this relational databases, they were invented. All of us know how it came about, yeah? In 1970s, this model was proposed to store data in tables, like we do in Oracle and MySQL, SQL Server, Postgres. So we are storing data in tables, and SQL can only query data which is in tables. SQL does not understand documents or JSON or text. You cannot query through SQL. So SQL is designed to query tables. So the relational databases that we use today were invented by IBM. The idea was given by IBM, but the first implementation came by Oracle at the end of 1970s for the first implementation. And then in the early 1980s, someone invented SQL. I think it was Oracle, or maybe it was IBM. I'm not sure. So then we had this. The first database was Oracle, and then we had the first query language, and it was an immediate, hit, an immediate number one. So because it was the need of the moment, and still we are doing the same thing. We are storing data in Oracle and MySQL, SQL Server, so even 30 years down the line. So it's such a fantastic technology. So it went pretty well till 2000, 2001, 2002, until Google. So Google actually allowed people to gather more data due to their search engine. So people started to look for queries and look for different things they wanted to run their business. And then they started getting data, they started getting information, and they started putting that in their databases. And then they realized that something is going wrong because the size of the database is increasing. And then we had these mergers, we had collaborations, we had different sort of acquaintances, we had MOUs. The data started to increase because of that as well. And then we had the social networks. So LinkedIn, Twitter, Facebook all came in 2004, 2005, 2006 in this time period. And they led to a huge, blast of data in the organizations. So that's where the big data became a big problem around 2005, 2006. So people started working on that and they came up with many different solutions. It's been more than 15 years now. And some of the solutions have been really fantastic, like Hadoop and MongoDB are, I think, the best ones. And for the more technical people, we have Redis as a database which can manage big data. So you'll go through these things later on in the next semester. But I'm giving you a heads up, okay? So we have some small foundation right now which I gave you, but we are going to discuss this in more detail in this lecture as well. So today's lecture is about the introduction of big data, how it came about. And towards the end of the lecture, obviously we have to start wrangling. What is wrangling? What do you mean? Why do we need wrangling? Why do we call it wrangling? What other names are there? Why it is important? What if I do not do it? So all of these questions you need to understand. And if you don't ask questions, then you don't learn. Just remember this, because I do not like a very dull way of teaching, and students just listening and I'm feeling sleepy, you are feeling sleepy. But the diploma was not designed to just get the diploma. So even if you get very low marks, but you learn, then your purpose is fulfilled. Don't think about first position or second position. You need to ask questions. That's the way to learn. So the more questions you ask, the more you learn, the more all of us learn. If you don't ask questions, then it's not enough. So the rule is, whenever you have a question, you immediately arrest my talk and raise your hand and ask the question. Don't wait for me to finish the lecture. Just we are built real time up. You need to ask questions. Otherwise, we are not learning. Okay. So some of you are into the stuff. Some of you are from the CS background. Some of you are not from the CS background. All of you have different ideas. The people who are not from the CS background are basically have a different notion of data analytics, right? So they want to understand things so that they can probably lead a team later on, or hire someone to get the benefit out of that. And the people who are in operations, they are looking for like maybe promotions or other things, a new job. So they will have the control, especially the people who are coming from the IT background. They are most likely to get the control from this diploma, the understanding and all those things. but everyone can benefit. Kapil, yeah, can you ask? You can ask the question.
Sir, I still don't get what's Hadoop and MongoDB. Can you just give me a brief explanation
You
about that?
you don't need to worry. You don't need to worry about MongoDB right now. We are going to be discussing many things in this lecture, and you will find it very interesting, inshallah, because there's going to be lots of hands-on, which will be also easy for you guys, not difficult. So don't worry about the fact. I know that not all of you have a programming background or a programming, skill. So we are going to make it easy, but we have to stick with Python. We can't do any visual. We can't use any visual tools because they are not being used in the industry. If you want to do a small research project, yes, you can use RapidMiner or you can use Nime. For example, I use RapidMiner and we have Dr. Sajad who uses Nime. So if we have some small task to solve in our research arena, we can use that. Yeah, because that helps us to arrive at the results very quickly. But from the industrial perspective, you have to go towards Python because that's what's happening in the whole world. So if you take a BDA diploma from IBA or any other place and you go abroad and you say that I've used this visual tool, you find the world is using Python. So how you're going to compare yourself with others? And your developers are going to be more powerful than you. So visual tools are only for maybe C-level executives, but not for us. So you have to adapt. Okay. Kapil, right now there's no need to worry about the, um, you know, the fact that MongoDB kya hota hai, what is Hadoop. We are going to be touching those things later on in other courses. Okay. So this is the education I have. A levels from KGS, JIK Institute, masters from Paris. I am a computer engineer by profession, and my masters and PhD are primarily in machine learning. Um, and I have stayed in FAST for 4 years and PFQ 3 years, and IBA. This is in fact the 6th year. So over the last 10 years, I have done multiple consultancies for different companies. So Vectracom, Next Degree, Codex, and FTI. So all of these have been like part-time projects role. I was never permanent anywhere or going regularly. They are just small tasks, and most of these tasks we have solved in the academic arena. So I've taken the projects from the industry and given to the students. So even now I have the master's program. I'm the coordinator for the master's program. So in the master's in data science program, we are looking for capstone projects from the industry. The industry gives us a problem and we get it solved through a project of 6 months or maybe 1 year through our students. So that's what I've been aiming for ever since I joined IB. Alhamdulillah, I have currently we are implementing 2 to 3 different projects in healthcare sector right now. So I work in data science or machine learning, BDA, data governance also. I have some knowledge about that, BI and data warehousing. So BI data warehousing are primarily from the undergraduate studies. So to the undergraduate, I'm teaching BI and data warehousing, which is a combined field, but we take it in 2 different courses. And in the graduate, I'm looking more towards deep learning, machine learning, big data analytics, which are complicated courses to teach. So I have to struggle a lot, but we are trying to teach the students, and the same policy goes for the BDA diploma as well. So that was a bit of an introduction. So here we start with this, what can you do with the data? So let's talk about what is data. Data kya hota hai? What do you mean by data? Huh? A pattern? No, patterns exist inside the data, but patterns are not data. Who can tell a good definition of data? Yeah, information. That's a good word to use. Data is observations are also good.
Observation.
Yeah, observations can be data as well, but I think an observation which gives you information is data. So if I have an e-commerce transaction by a person who comes online and just logs on to his e-commerce website, logs on to his account, searches for a book, and buys a book and then logs off. So this is, let's say this is one session and consisting of multiple transactions. So this is giving me information about what the user did, right? So in this way, in one day, if I have 500 customers who are doing the same thing, so 500 customers come and buy different things from my website. So I have 500 different sessions consisting of multiple transactions, and all of them are telling me multiple things about the customer. Okay. So imagine that this information of e-commerce data gets logged in your database. So what's a database? Collection of information. That's data. Datum is the singular. Sorry. Nini, what's a database?
Place
Platform.
where data is stored. Platform where data is stored.
But platform, what is a platform? Environment.
Junction.
Platform, environment, arena. Repository is a better word, or you can say, yeah, any repository to store the data is a database. You call it like you have a warehouse. Warehouse ka maqsad kya hota hai? We want to store things in a warehouse, right? So where to store the data? The first thing to do with the data is to gather it. Okay, you know that data exists somewhere, it's being recorded somewhere, and you want to pull it so that you can analyze it, obviously. So the first thing to do is to think about how to get the data, and when you get the data, then you where to store it. Okay, so always you store the data in a database. So you can say it's a platform. I don't think so. Platform is the right word. Repository, I think, is the right word. Or you can say a storage medium for data. So storage medium can include like interpretation for both hardware and software. So it's a medium, so that means you need hardware and there must be software. Hardware alone does not do anything. You can have a machine, i7 machine with 32 gigabytes RAM with GPU installed, but if you don't have the operating system, you can't use it. Okay. So database always comes with its own software. That's why you have Oracle and SQL Server, because uh, we can't manage the data at the hardware level on our own. That's a thing of the past, when people used to directly program the chips through assembly language, but or microcontrollers, they used to program them directly. Still they do it, but as software guys, we don't have that expertise, and it's not our domain. Our domain is to make use of the data to run our business. We are not worried about what happens at the hardware level. Okay, but at the hardware level, where is your data stored? You see the folders in your Windows and everything. So where is that data being stored? At the hardware level, आपके PC के अंदर हार्ड डिस्क, और आजकल हार्ड डिस्क कौन सी आ रही है? SSD. What does that mean? What does that mean, SSD? Solid state drive. What does that mean? I think it stores data in electrical signals, to electrical signals. And the traditional hard disk that we have in our systems is a mechanical way of storing the data. So you have the head which moves around the whole hard disk to discover the data or store the data. So it's a mechanical hard disk, and SSD is a electrical. It stores the data in through electrical signals. Okay, so it's very, very fast as compared to the hard disk. So after maybe 2 or 3 years, everyone, I think, is going to have an SSD rather than the traditional hard disk drive, which we HDD isko kehte hain. So is it clear? Everything is clear right now? No, you can't. No, computer science is not an umbrella term for data science, not at all. Computer science is the collection of all technologies um, that can help you get the computer to do something. All the technologies together are called computer science. Primarily in computer science, we are focused more on the software technologies. For example, we have software engineering, we have database softwares, but it also includes the hardware side. For example, we have operating system. The operating system is the software which sits on top of the hardware and controls the hardware. So you understand about memory management, about how the data flows between the different components of the motherboard, etc., etc. So computer science is a very, very generic field, yeah, which includes everything you can do with respect to the hardware and all the basic ways in which you can use the computer. For example, computer science can also include computer
सर
graphics.
चार्जर क्यों नहीं लग रहा?
Sorry, I think
सर
there's
चार्जर
a
यही है ना? क्यों नहीं चल रहा? लाओ निकालो तो बंद ना हो रहा.
okay, all are requested to mute. Otherwise, we're going to be hearing personal things. Okay. Yeah, so computer science has been there since 1950s, you can say. In 1950s, maybe we had Alan Turing, who was, I think, a British working in the British military. He was a spy. He was not a spy, but he was an agent of the British military, something like that. But he had a very sharp mind. So he laid the foundation for computer science. He wanted to invent intelligent computers. So the first computer came into being, I think, in 1947 or something like that. And Alan Turing wrote a paper in 1953 or 54, I think, in which he asked the question, can computers think? So he wanted to make the computers more intelligent, more usable like we have right now. So he laid the foundation. And after that, computer science started to develop as a field. Before, the computers were very, very large, like one computer in one room, and it was just primarily a calculator. But after that, we had the advent of the semiconductor technology, which forms the motherboard these days. So things started to move very rapidly. We came up to small computers and then we personal desktops. The idea of the personal computer was given by, I think, Apple. But it was, I think it was formulated by Microsoft first. So the idea was, I think, was Macintosh. It was given by Apple. But I think Bill Gates profited more from that idea, and Apple came on later. Or maybe it was, I'm not sure. I think it is attributed to Bill Gates. So I mean, the first personal computer that became usable for us had the Windows software. Okay, so it is more attributed towards Microsoft. So computer science is all that history, right? We in the computer science we saw neural networks, which you're going to study in your next semester, inshallah. And we saw different technologies like operating systems, and we saw software engineering. All of these fields developed. Then the 1970s saw the advent of the databases. They started to develop. Then we had the statistical softwares, which were analyzing the statistical properties of the data since the last 25, 30 years, or maybe even 40, 50 years. We had very old statistical tools, and they were there before the start of data science. So data science is all built on statistics and mathematics. So we had concepts from linear algebra, from other mathematical domains, optimizations, other probabilistic concepts we have there, which were being used since the last several hundred years. So before the softwares that were developed, they were used to analyze the data statistically. Okay, so like we can find out the mean, mode, median, we can do regression. Okay, we can plot the box plot, etc., etc., to understand the data. So before we had the softwares, but then came data mining, and then came data science, and now we call it machine learning. And now couple that up with big data analytics. So we'll see how these terms are related to each other. So your question is that computer science is not is not an umbrella term only for data science. It's an umbrella term for a lot of different technologies, which all use the computer for different purposes. Yeah, let me check if I have it in my slide here. Yeah, we're going to be discussing this. We just have to hang on a bit. Okay. Okay, so we talked about data. We talked about the information that the data gives. So we were talking about the e-commerce scenario. Regarding the supply chain scenario, supply chain involves things like manufacturing, inventory, deliveries, and sales. Okay, so the biggest problem I think in supply chain is the inventory optimization. Okay, you must, if you disagree with me, then you can tell me, because maybe I'm wrong. Okay, inventory optimization is a huge problem because either the stock runs out or the stock is left behind. So you don't want these two situations, and this is dependent on the manufacturing, on the delivery, as well as on the sales. So we have two things pulling from one side, other thing pulling from the other side, and it's not very easy to maintain a reasonable amount of stock which does not run out. Okay, and also which does not gather itself. Okay, then you have to put those sales which we see 50% off, 70% off, and that is basically you are losing money. वो अलग बात है कि उन्होंने वैसे इतने पैसे कमा लिए होते हैं कि उस सेल लगाने में फर्क नहीं पड़ता, लेकिन typically they don't want it to happen. Okay, so imagine the data for a supply chain. कि manufacturing को आप, you are telling the manufacturing company कि I need this order next year, इस महीने तक मुझे ये मिल जाना चाहिए. By the next year I should get this order in advance, because as per my knowledge, you have to order for the supply chain several months in advance. Manufacturing ka jo company hoti, you have to order them like 1 year in advance. Okay, next year these are going to be the prints, these are going to be the information, the things that we want. So you just do a calculation and you give them. But what happens is that, okay, that data could be huge. So you might have tons of attributes. Okay, you might have like 40 to 50 different attributes. You might have different tables. You do understand about tables and attributes, right? All of you do. ये तो इसका तो पता होगा how you store data in tables. The data, when you store data in a database, you store them in tables, right? ये तो अब जैसे मैं बात कर रहे हैं, तो you do realize how that happens, या नहीं? So let me just do the whiteboard. So just no issues. You have to get comfortable with this as soon as possible. So this is the table, you can say. I'm sorry, this drawing is going to be very twisted. I don't have that stylus right now. So this is the basic format of a table. Okay. So here we have the columns. So we have C1, C2, C3, C4, C5. And the data is stored in the form of rows. Okay, so one row is primarily one unique entity. So if this is a table for, let's say, manufacturing order. Okay, so one row is going to represent data about one order. Okay, and what can be the potential attributes? Can you identify? The quantity of product, the type of product, the size of product, the weight of product, the print of product. So all of this thing will occur in one row. So one row is an atom. It represents a unique, complete set. You can't break a row. Okay. So if I have multiple orders, so obviously there will be multiple rows. Okay. Is this thing okay? What if this is the table for the inventory level? So I just write that down. This is a table for inventory level. What are the potential attributes that tell you the inventory level? That's right. Location, any Let's say we're talking about clothes retail. So location of the store and
quantity of clothes.
so some information, some attributes about the product name, product
Hmm.
sub name, product group name, hierarchy, जो उसकी बनती है product की. Then the location of the store, etc., etc. The time, obviously, that's time is a default column in almost all the databases. So you can't work without time. So timestamp is going to be there, and then obviously the level. Case of the stock, kitna hai, how much stock we have right now. So if I'm measuring the stock at weekly basis, so I will add one row after 1 week and then rewrite the stock at that time with all the data. Okay. So in this way, I can identify the columns and the rows for anything in the world, any data in the world. So let's say this is the table for flight reservations, online flight reservations by the passengers. Let's say PIA or AirSeal, whatever. So what are going to be the attributes in this case? Huh?
Types of seats, adults, children.
Yeah, types of seats, children, yeah, the destination, source, etc., etc. Yes. I think you get the basic idea. So the databases that we have, like we have Oracle and SQL Server, MySQL, which are being used in the whole world, store all the data in the form of tables. And in one database, we have multiple tables. We don't have one table. We have multiple databases